Introduction to Statistical Learning, and we're in Chapter 8 and Question 8. Here's all of the questions, and so we'll just come to them one at a time. But basically, we're going to be using different methods that we learned in this chapter to assess the Carseats data, looking at sales and trying to predict sales based on other variables in the data set. So here we go. So first we need to install a few packages here. There'll be actually a couple more that we need to install later, but but the important one here is ISLR2 because that's where our data set comes from, and we need the tree to do some of the operations that we're going to do. Okay, so part A is we need to split the data set into training and test set. So this has been done a bunch of times. There's different ways to do this, but you can see how I've done it here. So do it however you like. But the first kind of big thing that we're going to do is we're going to fit a regression tree to the training data, to X train here, and then interpret the results, looking at test MSE to kind of see how good we're doing here. Okay. First we're going to just use the tree command and do sales being, call this regressed on. I don't know if that's really the right word, but this period means every other variable in the data set, and here we're using the data set dtrain, okay, the training data set. And then if we just plot this and then use text that fills in where all the text goes, and you get this guy right here. And it doesn't render very well. If somebody knows how to make this look prettier, and let me know in the comments, I would appreciate that. And maybe anybody else watching this video would appreciate that. I could not get it to look prettier. So, roughly what we have here is, you have this this fitting algorithm that's going through and trying to look for, the most important split. And then splitting the data along that particular split, and then doing it again for the next variable and the next split, and so on and so forth. So hopefully you're familiar with how the tree algorithm works. And then we need to look at the how well this is predicting. Give it a score, and that's going to be the MSE here. So I'm going to predict based on the model M, and I'm going to use data from the test set, right? And my MSE is going to be, well, it's going to be the difference of what's predicted versus what actually happened squared, and then I take the mean for my mean square error, and I get 5.1 or whatever. And then here I've also plotted the predictions on the y-axis and the actual values on the x-axis. Okay, so there you go. Okay. Now in part C, we are going to prune our tree. We're going to prune our tree using cross-validation to find, the best set of cuts and variables. Okay, and so in order to do that, we use our cross-validation.tree command here, and then this gives us deviance terms for different sizes of trees, and so we pick the best, the smallest of these deviance sizes, and so then I use that information to then prune the tree based on what seems to be the best number of splits here. Okay, and we get this guy right here. Okay. So this is our pruned tree from, we pruned the tree that we generated in part B. And so when we go through and look at maybe how well it's fitting, we can calculate the MSE here, and we get this value, which in this instance is greater than is greater than the previous mean squared error that we found, where we had everything, but they're both being ran on the test data. So I think that might just be an anomaly of this particular set of data that we generated. Test set and train set that we generated. Okay. So now in part D, we're going to use another method, bagging. And so, so with bagging, we're generating bootstrapped, excuse me, bootstrapped samples, fitting, whatever model we're going to fit to it, and then doing that several times, and then averaging the results. Okay, so that's roughly what bagging is. And so you can see how we do this. And so I use the command random forest to do this. And why? So bagging is just doing random forest, where the number of predictors that you're using is all of the predictors that you have available to you. Random forest, we usually pick some subset of predictors. Okay, so here you see when so the number of predictors that I'm using is all of my predictors, the number of columns in xtrain. Okay. So anyway, so we go through and we find predictions, and then we compare those predictions to what actually happens, square it for our MSE, and so we get our mean squared error. We get our mean squared error right there. We're also supposed to try to say what variables are most important, and so we can do that with the importance command here. So so we run it right here, and we get the different variables. And so we can kind of judge how, quote unquote, important any particular variable is by looking at the, the node purity values right here. Right. So, so it looks like the most important one is the shelve lock, followed by price and some others. So, if we compare that actually up here to the tree, we see that gets replicated fairly well in the tree that we did in part B and C here. Okay, so now for part E, so now we're going to use random forests, and remember, random forest is just well, how do I want to say this? We just did bagging, and bagging is a special case of random forest where we use all of the predictors. And so in random forest, we're going to use less predictors, right? So that's what we're going to do. So to do this, I am going to calculate I'm going to calculate MSEs for for one predictor, two predictor, all the way up to all of the predictors here. Okay, and so I'm doing that with this for loop here, right? So so I have a for loop, and I'm saying how many predictor variables I. Well, what's I? I goes from 1 to the length of to the number of predictors that we have. Okay. And then I calculate the mean squared error for that, and then here I'm plotting the mean squared errors. And in this particular case, maybe I shouldn't have done that. Give it a second to run. In this particular case, it's about 5. 5 predictors seems to be the best. That will vary based on the run, and so when I was first doing this, it was 7 was the best. So so we'd have to we'd have to modify this here. I'll just put it at 5 right now. So so I'm going to pick the best here from that previous for loop, and we'll look at the importance of this. And again, it looks like shelf lock and price are kind of the 2 most important ones. Okay. And we also need to find the MSE, so I take my predictions here, and compare it to the actual values, and I get a mean squared error of 2.63. Okay. Now finally, we're using BART, which is, what does BART stand for? Bayesian additive regression trees. Okay. You can look at the algorithm of how this works, but basically we're fitting models sequentially based on the residual from the what is left over of the prediction from the previous little models that we're running. That's not a great explanation, but so we need to load the BART package. Okay. And then in order to run BART, we use this command right here called gbart. If we want predictions out of it, we need to specify what our test data is, which is x test, and then it tells us what the predictions are with this command, or with not this command, but this object within the gbart object. Okay. And then we can get the mean squared errors out of all of that, and here we get 1.42. Okay, so along the way, we've looked at all of these different methods, and we got an MSE out of all of them, and so I've maybe run it one more time. So this is what the mean square error was for all of them, and in this case, BART here is doing the best out of all of them. Okay, we'll call that one good.